Good morning. So this is going to be the last video that I shoot for this particular set that is on the bench. Okay, so after this I'm going to mount it on a robot. And what I wanted to do is talk to you about hooking it up to RC control. And so I've already kind of hooked it up here. In fact, I have hooked it up here. But I'm going to zoom in so you can really see the way that I've done this. Okay, so this is a 6-channel RC receiver, all right, and I have a ribbon cable of 6 wires that are going from channels 1 through channel 6 or 0 through 5, and I've hooked it into the Teensy output pins of 7 through 12. All right, so it's a straight connection. Over here, where the battery hooks up, I have this 2 filament wire connected to this side of my motherboard, supplying 5 volts. Notice that the black wire is on the outer edge. The red wire is connecting to the inner set of pins. These are the ones that are going to be powered. It's tethered with this USB, so it's getting 5 volts from my computer. I won't even need to turn on this switch because I have nothing from this RC hooked up to the power supply in this side of the board. Okay, so it doesn't, the signal pins will be unaffected. So I'm just going to be taking data from this receiver into these pins here and then processing them, and then we're going to look at it displayed as a printout. Alright, so let me zoom back out a little bit so we can kind of see the big picture here, and let's look at some code. Okay, and I have this posted. It's pretty straightforward. So first thing I did was create 6 variables that are going to hold the information that we gather from the pin. In the setup, I have set all those pins that are connected to the RC into input. Okay, so they're able to receive signals. In the loop, go back down here, what I'm going to do is I'm going to collect the pulse width. Remember, RC controllers are designed to run a servo directly, and even again my little diagram down right here, what that does is it sends out a signal between 1 and 2 milliseconds with a 20 millisecond delay. So you can plug your servos directly into this. Normally you plug them straight into this receiver and you can drive your device directly. Since you're going to want to have an autonomous function, what we're going to do is we're going to collect this data and we're just going to hand it off. We're just going to pass it right through the processor. But we still have to collect it. Okay, so we're going to take a pulse in measurement. And if we look on the web, okay, to the pulse in function call on the Arduino site here, you can see it's pretty straightforward. We're going to be using 3 arguments. Okay, the pin which it's connected to, in this case between 7 and 12. The value, this is whether or not I'm looking for a high signal or a low signal. And this is important, timeout. Okay, this is an optional setting, but I think it's important. We don't want to have this thing go on and on and on and on waiting for the signal. So if it has not received a signal that it can decipher within a certain period of time, let's just skip it. Okay, and I set that, remember the pulse, the dead time should be 20 milliseconds. So I've set mine at 2100 milliseconds, or 2100 microseconds, or 21 milliseconds. Okay, and then if it doesn't get it, it's just going to give up and skip. This is important. Okay, the computer is running in a serial fashion. So when you think about it, just to collect all 6 pieces of this data, it's going to take 20 times 6, or 120 milliseconds just to make it through. Okay, because it's going to go here, it's going to collect, then it's going to go here and going to collect, to go here and collect. Each one of these things are probably going to take 20 milliseconds minimum. Okay, and then it finally repeats. So what I do in this case is I collect all that data, 120 milliseconds later, whatever it is, I jump to the print RC command. Print, literally all I'm going to do is take and output that data. I'm also going to do a bar graph, which I think is handy to see how things are working. And when I call my little bar graph function, it goes down here, and what it's going to do is it's going to take the value that it collected, okay, and it's going to first off subtract 1,000 from it, because the minimum value is 1,000, so we're going to bring it closer to 0 so we can scale it in appropriately. There's no reason to print 1,000 dead spaces before we even begin, so we're subtracting 1,000, and then I'm taking that whole bunch of data and dividing it by 10 so that when I do get my bar graph, there's no reason I want it to be 1,000 spaces long. I'd actually like it to fit within 100 so it fits easily on a viewing window. Okay? And then it's going to print that many spaces, and when it gets done printing that many spaces, it's then going to put out a star, or you can make it whatever you want. And it's going to do that a total of 6 times. So I think we're actually ready to load this up. I have my RC transmitter here, and let's go ahead and load it. And now I'm going to open up. Okay. And it's actually scrolling down. You can't see it. I've moved the screen in such a way it appears frozen, but if you look at this, you can see it's getting smaller and smaller. I'm going to turn on my transmitter. And actually this is worthy of seeing. I'm going to zoom out here. You can see the light turning on and off on the receiver as I turn on and off the transmitter. So it is in fact handshaking. You should be looking for that. And here we go. We are on. So if I move, I'll hold this up in such a way you can see. Here's channel 1. Okay. Channel 2. And then we have 3 and 4 here. And 5. Okay. And 6. So we've definitely got data coming in. We've handshaked, we've printed it, we displayed it. We can start looking at these numbers and deciding how you want your robot to behave. So I'm going to actually do that next. I'm going to hook it up to a robot and we're going to play with it, and I'll see you guys shortly.